Is a healthy, established biofilm on the rock or tank microbiome a real thing? Can it be measured with eDNA, or is the term healthy and established just a state of being and forever a black mystery box? This is BRStv Investigates the Biome Cycle, and it's time to see how AquaBiomics eDNA testing can crack the black box. AquaBiomics environmental DNA testing offers a totally new window or tool most of us have never seen or know how to use. Today we'll take that next step and learn what eDNA testing is and how to use it in a reef tank. What does good and bad eDNA report look like based on some established tanks like the BRS-160 as well as 12 experiment tanks? I don't believe anyone will look at Biome like a black mystery box again. We have the data now. The question is, how do we use it? Never heard of eDNA testing? eDNA is short for environmental DNA. As living organisms move through their environment, they shed genetic material. eDNA testing surveys that environment, in this case the water and surfaces, and tests for the presence of material to identify which organisms are present. This type of testing is particularly advantageous for detecting aquatic species that are hard to otherwise observe, microscopic or in low population densities, but they do shed DNA throughout the aquatic environment, in this case our tanks. The AquaBiomics eDNA test looks like this: a large filtered syringe of water from the tank and a surface swab of a dark high flow area of the tank. Send in the sample and they provide you a report of what the DNA sequencing says is in the tank, as well as a window into the population ratio to each other. The results or report looks like this: a basic indication of diversity and a sheer number of bacteria and of archaea types in the tank, as well as how that compares against other healthy tanks that they test as a percentile in brackets. A 12% means that 88% of healthy tanks have tested as more diverse than yours. There's also a portion for balance, which seeks to give you a window into not just how many organisms are present, but are they the right ones, and are they in a ratio similar to other tanks that they've tested. 0 meaning no, and a 1.0 a perfect match, with the percentile in brackets as well. Keep in mind, no tank will ever look exactly like another. There are too many variables. What we're looking for is reasonable similarities and explanations for dramatic differences. Below that are all the major families or contributors to the microbiome in the tank. This is what a typical balanced sample looks like: slivers of different families and relative balance to each other. Anything that makes up more than 1% is represented with a bar. There are a lot of families here and a lot to learn. However, like most things in the world, there is an 80-20 here, and roughly 5 families make up a vast majority of what populates the tank. AquaBiomics shared some insight into each of these 5, and in many cases, what they're related to does show up in our established donor systems and the 12 experiment tanks as well. This is the quick AquaBiomics crash course on the 5 families. While the names are complex, the basics behind them are pretty straightforward, starting with Vibrionaceae. This family is found in nearly all established reef tanks, but not in many newer reef tanks. The reason is its close association with feeding on animal surfaces, fish, and coral mucus, decaying crustaceans as well. So this family would be more dominant when there's a reasonably high density of fish and corals in the tank, and often absent when there isn't. You'll see that in this experiment. Next up, Rhodobacteriaceae. This family's predominant contributor to the tank's biofilm on the rock and sand and other surfaces in the aquarium. What's interesting is this family is not found in high levels on most pristine offshore coral reefs with low nutrients, but does populate inshore high nutrient reefs like lagoons. Not all that different than most reef tanks, which often share more similarities with high nutrient input lagoons than pristine offshore reefs. Next, Pelagibacteriaceae. This group of bacteria often populates the water column rather than the rock and sand surfaces. This family is adapted for life in low nutrient waters of the open ocean and a major family on natural coral reefs. 2 important things to know about this family is it's rarely found in newly established reef tanks, and in AquaBiomics testings, something that shows up over time in established reef tanks. This is also a major family that will be affected by UV because it lives in the water column rather than on surfaces. We'll discuss how much that matters in this series. Next, Oceanospiraceae. This group is present in most established tanks and another free-living, open water group. But this one prefers high nutrient environments instead of the low nutrient habitats preferred by the Pelagibacteriaceae, which may provide a window into why one would be dominant. As a general rule, this group prefers organic acids like amino acids or acetate, and often blooms in response to carbon dosing or the use of probiotic bacterial products, which often contain vinegar. Next up, Alteriomonadeaceae. This group does well in higher nutrient conditions, as well as those with a lot of nuisance algae. They do especially well with carbohydrates like those released by algae, so they often bloom in tanks with lots of nuisance algae or macro, and in some carbon dose tanks as well. They can grow on a wide range of nutrients, so they're pretty much universal in reef tank communities. This did seem to be true in all of our experiment tanks. Keep in mind that this type of DNA-based microbiome exploration of our tanks is in its infancy and evolving. These explanations of what these families are and what they do is not meant to be absolute. In fact, with every test of a healthy or unhealthy tank that AquaBiomics receives from the reefing community, that data set increases. The information and how it's interpreted will evolve. This is a journey and it'll be valuable to us all. Next up, what does a good and bad microbiome look like? Starting with bad. If a high diversity and balance score and breakdown that looks something like this is the goal, what does it look like when it's not going well, which is just as important? This is 3 types of bad, all taken from week 2 biome snapshots in a few of our experiment tanks. First, this is what throwing an established biobrick in a sump looks like 2 weeks later. Clearly not diverse or anything approaching a normal balance, with one of the 5 families taking over 60% of the tank and clearly winning the early stages of the microbial war. Another form of bad is the control of dry rock and dry sand. It looks fairly diverse, but almost none of the 5 major families found in typical reef tanks are winning the war. In fact, it looks more like the Wild West than it does a healthy or informed method of building an ideal microbiome. Not a surprise with dry rock and dry sand only 2 weeks in. Another example of not going well in the first 2 weeks is the real reef rock and dry sand. Both not diverse, and on the top of that, none of the major 5 families are present in any major degree. The wrong things are winning the microbial war. This is something that changes over time. Okay, so now that you know what bad looks like, what does good look like? Let's look at 3 established tanks here at BRS. Note that none of them will ever look exactly like the typical tank, because that's a mythical creature based on a blend of healthy systems reports. Good will just look a lot more like this than the ones that we just showed. Starting with the BRS 160, which has been up since 2015 and one of the most well-known and documented tanks in reefing, clearly both diverse and twice as many measurable organisms as the ones that we just mentioned. A biome balance of 72 are better than nearly 3/4 of the tanks out there, as well as a ratio close to a typical sample. Not surprising that a 7-year-old tank with a ton of coral would be both diverse and balanced. In terms of the 5 major families, 4 of them are clearly present. Alteriomondaceae is dominant, particularly because we have a large fuge in the tank, creating this family's preferred food source of carbohydrates. The one low nutrient preferring family, which is predominantly open water, is not present. Normally this would be associated with UV, but UV hasn't been on in this tank for a long time because it was not plumbed ideally in 2015. So this is where some of the debate begins. Why are some of these families not present in such an established tank? The answer is an introduction source is only part of the equation. This is all going to change based on the ideal food sources, habitat, competition, filtration, and even predators. So is one family missing, surprising, or concerning? The answer is no and no. This is a 7-year-old tank. It's found its balance and thriving. Overall biome looks a lot closer to a typical sample than the 3 bad samples, and why this tank ranks better than 72% of the tanks out there. Good example number 2, Steve's tank. This tank has been up for almost as long as a 160, just as diverse and looks balanced with 4 of the 5 families present. Interesting to note that the free-living Bacteriaceae is not present here either, and this tank has never had UV. The takeaway is the absence of some of the free-living bacteria in the 160 or Steve's tank is not preventing success. Example number 3, the 900, this is maybe the most interesting because it represents what we're actually attempting to do with many of these test tanks, which is biome cycle a tank rapidly. The 900 had only been up for 7 months when we took the eDNA sample, but 100% of the rock came from a multi-year reef tank at New Wave Aquaria. Water from established tanks and multi-year media bricks from established tanks were placed in the sump. If there was ever a way to insta-biome cycle a tank, this seems like it would be it. And yes, it worked. Oddly enough, the diversity was really low and similar to all our newly established experiment tanks, but the balance percentile was 100, meaning it outperformed nearly every tank in terms of balance and having the right things rather than the most. All 5 major families are present. The obvious question though is, how can it rank in the 100 percentile when it does look different than the blend of typical samples? It's because, well, it's not a perfect match to that blended average or score of 1. It's the closest, or amongst the closest AquaBiomics has ever tested that average. The tank results match that. So when we look at the balances in these 12 experiment tanks, don't look for the perfect matches, but more so that it retains much of the good as possible, avoids the bad or the Wild West, and when do the expectations from the DNA results or unseen match what we can see? We're trailblazing new concepts in reefing. We have access to new data. Progress will be found in how we interpret it and how large the data set becomes. After performing these experiments, I've seen enough to believe that environmental DNA testing will be a component of unlocking the mystery to what a healthy microbiome or biofilm is, what it looks like, how to intentionally or purposefully create it, and why it will contribute to an easier path for us all. The proof will be in the results, and that's next. The first 4 tanks, wet Indo live rock, the control of dry rock and dry sand, our sterile approach, the ocean direct sand, and 2 cups of donor sand from an established tank. Some of these we would never do again, and learning what not to do is the first step in finding the right path. That's right here, the first set of results.